Hey everyone, Morgan coming back at you. We're going to be going over the worksheet on atomic structure number 2. Now, we did not assign atomic structure number 1 this year, but it is available on the webpage if you want to practice some more. Before you start to do this, you're going to need your calculator and you're going to need a periodic table, and it really doesn't matter which periodic table you use, okay? They all pretty much work the same way. Okay, so in these symbols, these atomic symbols, the bottom number on the left is the atomic number, and the number on top is the mass number. So for barium, the atomic number is 56, which means the protons are 56 and the electrons are 56. Now the mass number is 137. So now, if I take the 137, subtract 56, I get 81. And that's the number of neutrons. So for rubidium, 37, 85, 37, 37, and then I can take the 85 minus 37 and get 48 neutrons. Okay? Technetium. Atomic number is 43, mass is 98, that's a 43. That's a 43, 98 minus 43, and I have 55 neutrons. Okay? These are pretty straightforward. You'll be needing to do this on your test, so get good at it. 31, 70, 31, 31. Okay, and that should be a 39. 70 minus 31, 39. Just double checking my arithmetic. 34, 79, 79, 79. Then I take, I messed that up. I apologize. 34, 34, and then 79 minus 34, 45. Now, what if we don't have the information presented to us this way, but I give you some other clues? Atomic number 2. Look at my periodic table. Atomic number 2 is helium. Okay? The mass number is 4. So it's got 2 protons. 4 minus 2 is 2 neutrons. But, I'm being told there are 0 electrons. So that means that we have He, 4 over 2, and it's a 2 plus. Okay? Now, mass number of 20. Okay. That's looking to be pretty close there to neon, although there are probably some other isotopes of fluorine and sodium that I could potentially use. But with a mass number of 20, I'm going to call this neon. 20 over 10. Atomic number is 10. Protons 10. Electrons 10, it didn't say anything about a charge. 20 minus 10 is 10 neutrons. Okay. In this next one, I'm told I have 18 protons. 18 protons is argon. 18, 18, 18. And according to this periodic table, 39.95. And I can't write a fraction, so the mass number I'll choose is 40, and that'll make that 22. Okay, there are some other possible isotopes also. Let's not worry about that so much. 25, an atomic number of 25, because the protons are 25, the atomic number is 25. That is going to be manganese, Mn. Now, on manganese, 54.94. So I'm going to call that a mass number of, sorry, that 25 goes over there. A mass number of 55. So, messing that one up. 55 over 25. So that should be 25 electrons. Hold on. I'm told 23. That means I've lost 2. Let's go with the 2 plus there. 55 minus 25 is 30 neutrons. I forgot to put this in over here. 40, 18. Okay. Protons, 35. That's bromine. Okay. So atomic number 35. 35. Okay, mass on my periodic table, 80. Br, 80 over 35. 80 minus 35 is 45 neutrons, but ooh, wait. That's a 36. That's an extra one, so that's a Br minus. Okay? Now, number of protons, 38. That's strontium, Sr. Now, on my periodic table, strontium is 87.62, so I'm going to call that an 88. And then it's going to be a 38 down here. So atomic number is 38. Electrons, that's a 2 plus, because it should be 38, but it's 36. 88. 88 minus 38 is 50. Okay. Now I've got some interesting ones here dealing with chromium. They all are chromium, so they all have an atomic number of 24. They all have a mass number of 24. Now the masses here are 52, 53, and 54. Okay, electrons should be 24, but it's a 2 plus, so that's 22. Should be 24, it's a 3 plus, that's 21. And now, 24 minus 5, that's 19. So I'm going to get my calculator here, and I'm going to go 52 minus 24. That gives me a mass, or a number of neutrons of 28. That would be 29, and that would be 30. Okay? And you're going to have to do 20 or 30 points of this on your next test, so hopefully get good at that. Okay? Atomic number is 94, 94 protons, 94 electrons. On my periodic table, that is plutonium, that has a mass of 244. So 244. Take the 244 minus 94, and I get 150. A lot of neutrons. 106 protons. That's seaborgium. Okay. Sg. Okay. And that has a mass of 106. I'm sorry. No. Got that backwards. That has an atomic number of 106. And 271. Wow. 271 minus 106. That gives me 165. Okay. Atomic number of 7. Protons 7. That's nitrogen. My periodic table, it's a 14. 14 minus 7 is 7. Oop, that says 10. That's 3 extra electrons. So that's going to be a 3 minus. Okay? So there you go. That's the front page of that homework. Let's go over here and look at the back. Okay? Do a few of these for you. So lithium, we got a couple of isotopes. 6.015, that's 7.59%, and 7.016, that's 92.41%. Okay, so what's the average? I'll say x equals. I'll take this percentage as a decimal point. 0.0759, that's just dividing it by 100, and multiplying that by 6.015 AMU plus 0.9241, and multiplying that by 7.0160 AMU. Okay, now it's calculator time. So I'm going to take 0.0759 times 6.015 equals, and then add to that in parentheses 0.924 times 7.016, close the parentheses, and that gives me 6.939, so let's call that 6.94 AMU. Now, I go to my periodic table just to check. Lithium is 6.94. Hey, it worked. Okay? And I would basically do the same thing, okay, for these questions as we go down. Okay? all done the same way. Okay. Now, here's where things get a little bit different at number 6. This turns into an algebra problem, really. Gallium has 2 known isotopes with a mass of 68.256, which is 60.11%. Okay? If the mass of natural gallium is this, what is the mass of the second isotope? So I know that the periodic table says 69.72, and that equals 0.6011 times 68.256 plus another percentage. Well, I can figure that out. 1 minus 0.6011, 0.3989 times x. See, these two have to add up to 1, or as percentages, they have to add up to be 100%. Okay, so here's what I can do. Let's multiply those two numbers together. 0.6011 times 68.256 equals, and that's 41.028. Now what I'm going to do is go and subtract that on this side. So I can take 69.72 minus that answer, and I get 28.691 equals 0.3989 multiplied by x. So divide both sides by 0.3989, 28.691 divided by 0.3989, and that tells me 71.93. X equals 71. Let's go one more sig fig after that. 925 AMU. Okay. Now, in 7, I'm going to show you the setup and let you play with that. I know that the average mass is 85.47, which equals X percent times 86.9092. Actually, let's start with this one, 849118 plus. Now the other percentage is 1 minus X times 86.9092. And then you can go through and solve that algebraically. And I want to leave a little bit of this for you to try and do on your own. Okay, that is atomic structure number 2. Okay, folks, have yourselves a good day. This is Morgan signing off.